I am Guido van Rossum, and I work at Google. And here's a little bit of a plug. I should have checked this microphone. I'm a little taller than the average speaker here. Google is a great place to work. I mean, what I'm going to demo here is the result of me having a year of fun at Google. So if you want to join me, there's my email address. So I'm going to talk about actually a really boring subject, code review. I think most people probably know what code review is. In various places you'll find more or less formalized approaches to code review. The basic idea is one developer writes code, someone else reviews it. This is a voluntary thing. Now the review in the ideal situation is just a very careful critique of the code where you point out basically anything that you feel could be done better. There's usually a dialogue going on. You don't, as the code author, you don't have to do everything that the reviewer says, but you probably learn something. Now, the main point of code review is that it is done in a non-threatening environment. At my last place of employment, we did not do much code review, so I ended up reviewing a lot of code in a very stressful environment. That was a lot less fun. The point of code review is to make the code better. And in many places, it is a very much an integral part of the coding process. Just like some people do pair programming on principle, other people do code review on principle. So what are some of the reasons for doing code review? Well, of course, two people know more than one. Two pairs of eyes catch more bugs than one. When one person is sort of tired from half a day or a day of hacking, they're probably too tired to catch every single problem in their code. So it's good idea to pass it on to someone else who will have a fresh look. This can save a lot of time later on, because the general rule with bugs is always the sooner you find them, the better. And there is sort of all these different stages where you can find them. If you can find them while you're typing, that is the most efficient way of finding them. Of course, that doesn't always work, so once you're done typing, showing it to someone else who will see these sort of the obvious things that you don't notice anymore because you've been staring at it for too long, really helps. Another thing, and that is actually a pretty important part of code review at Google, is enforcement of, and I take enforcement in sort of an informal way. There's no style police here as such. Some people would wish there was. But coding standards and style guides. If the code is more uniform, it makes it easier for others to read it 6 months or 6 years from now, when that code develops a problem or needs to be extended. Another very important purpose of code review often is where a junior and a senior developer work together. The junior developer does most of the coding. The senior developer helps them understand the code base by doing a thorough code review and pointing out where they may have missed very subtle, often unwritten or written up in a sort of non-standard place, conventions or requirements or invariants and so on. This makes the new developer better because they learn. It also establishes a trust relationship between the two developers. Eventually, after reviewing a lot of code from a particular guy, I will know what he's good at and what I can let him do on his own or nearly on his own, and where I'll still have to help him or watch him. That is a great way to sort of gradually move people from junior to more senior positions. And Many people don't like the idea of pair programming. I find that code review is the best alternative to pair programming. It's basically asynchronous pair programming. It doesn't necessarily catch everything the same way that pair programming does, but there are only certain environments where pair programming really works. When one person is interrupted a lot because they have other responsibilities, pair programming doesn't work very well. But if you're being interrupted a lot, maybe doing code reviews for someone else is just another interruption that you can do in between other stuff. So of course, I've been doing code review for many, many years in an open source setting. And there you typically have the environment where I'm sitting here at my desk, someone else is sitting somewhere else at their desk. We look at the same code, but on different computers. There's no shared file system or anything. We probably have instant messaging, but the only thing you really can rely on is email for communication. So somebody, and again, in my situation, I've most often worked with relatively junior developers who had an idea for an improvement to an open source project. So they read the documentation that says how to check it out. They try to understand the code base. They find a place where they want to make their change. They compile it. Hopefully it runs. Their patch actually works. Now they have to get it checked into Subversion or CVS or whatever source control system you use. So typically in the Python world, for example, what we do at that point is we ask the author of a change to send a patch to someone who can review it. That used to be me. There was a time where I was the only person who could do Python check-ins, by the way. Now I'm the last person to do Python check-ins. There's a whole group, 30 or 50 developers who check in more than I do. Anyway, there's a pretty standard process where context diffs, or these days mostly unified diffs, are mailed around and subjected to pretty much the line-by-line critique that we call code review. Email back. Author improves their changes, sends another patch until the reviewer is happy. And in open source, the typical situation is that the contributor, the author of a particular change, does not yet have submit check-in permission to the source control repository. So it's actually the reviewer who makes the final decision and implements the final step of checking the code into Subversion. That's not always the case. I mean, in Python, we also have plenty of situations where a junior developer who has already received access to Subversion, they can check stuff in, but they don't necessarily feel comfortable checking stuff in before it's been reviewed. So we do the same process, email back and forth, or maybe the SourceForge patch manager, which to me doesn't actually necessarily make the process any easier. But once the reviewer says, okay, this is fine, then the author can actually check it in. That has certain advantages because it means that later on the Subversion logs will show who checked it in rather than who reviewed it. There is, and this is actually one of the areas where having a patch manager does help. There's a track record of who reviewed it and what the discussion was. And we've seen plenty of situations where issues with bugs issues with patches came up like 2, 3, 4 years later, and referring back to the discussion that led to a particular patch being checked in was very useful. Also, of course, again, the intense interaction between a submitter and a reviewer is a great way for the reviewer, for the most senior developers, to find out who are the good junior developers who should be encouraged to contribute more, and whose contributions can at some point stand on their own, don't need that much thorough review. So how do we do this at Google? Now, there's always theory and practice, and the difference between theory and practice is, how do we say that? It's larger in practice than in theory. I'm only going to describe the theory. That makes it a lot easier when this thing shows up on Google Video anyway. So we use perforce, it's no secret, which is usually abbreviated as P4, because it's a command you end up typing a lot. There is a single depot. And we use branching mostly for release management, but the individual developers do not have individual branches of the code. By and large, there are exceptions, there are groups that work in a branch, but by and large, developers work on the trunk. And there are good reasons for that, and it has certain advantages, and it has also certain problems. Another very important constraint is that as soon as something is checked in, it's live for everyone else, because we don't work with branches. So it's very important that we do the code review before checking in. And this is where all the fun starts. This is actually where we created a problem for ourselves that I spent some time solving. So one more detail of the Google development process: we actually don't use the raw perforce command line tool. Most of the time we use a wrapper around it, which used to be a shell script, and by the time the shell script was more than 3,000 lines, we decided to rewrite it in Python. Unfortunately, now we have a shell script of 4,000 lines and a Python program, because somehow the shell script didn't want to die, but it will eventually. It just takes time, like everything. And that wrapper gives us the ability to add additional functionality to perforce, some of which is very specifically geared towards doing code review. So here's what the code review process at Google looks like. And this is all command line and email based. So you check something out, you make changes, you compile it, you run it, you test it. Then you pick a reviewer. There is a certain algorithm for picking reviewers. If all else fails, you pick the guy at random who made the last change to the same file, of course. Then the reviewer has a little bit of a problem, because they have to review a change that's not yet checked in. Fortunately, having a single shared NFS file space actually helps at this point, because the reviewer, in theory, could just change into the author's directory and do a perforce diff right there. What we actually do is we have the G4 wrapper around perforce makes it a little easier, so you don't actually have to change into that guy's directory. The system finds out where the files are and diffs them for you. And there are some other tools, like there's a nice TK-based side-by-side diff tool. There's actually also a tool for sending the email that initiates the code review process. After that, it's mostly just email back and forth. And because we have this shared file space, there's one difference with the open source process, which is that we don't actually send patches around, almost never. You just send an email that says, I've addressed your changes, have another look. So we do this a couple of times. We reach agreement, and this is all a very collegial, friendly process. At the end, the author and the reviewer reach an agreement, and then the author can check stuff in. Now, there's nothing technically that keeps them from checking it in before it's been thoroughly reviewed, except that there are all sorts of things happening in the background that eventually point out that you have submitted code that wasn't sufficiently reviewed. So that keeps people honest, and it sort of keeps the process working without being too much of a burden. I mean, there are escape possibilities, like you made a terrible mistake, you need to check in a change right now, you can't find anyone to review it. Okay, well, there's a hook you can use to check it in right now, and someone else will be notified and they'll review it after the fact. Just don't do that for every change, because then you'll get a manager on your back. So the tools that were originally developed, all parts of the G4 command wrapper. First of all, and this is, I don't know how many people here actually are familiar with Perforce. No, not too many hands. So if you're familiar with Subversion, it's a little different. But in Perforce, there's actually a way to tell the Perforce server about a change that you're going to make without actually submitting it. What you submit is the metadata without the contents of the change files. So this metadata has a convenient number, and it contains a description and a list of the files and additional metadata that can tell the tools where the files live in the user's workspace. So that's the G4 change command. And basically what you could do at that point is G4 change gives you a 7-digit number, and you could mail that to the reviewer. There's actually a tool named G4 mail that does a little bit more than that, and it also does a bunch of sanity checks so that you don't accidentally submit something for review that hasn't actually been run through the compiler yet. So the tool that the reviewer uses to actually see what changes the author made is called G4 diff, which is like P4 diff, except it also can diff files in someone else's workspace. Finally, and this is actually a tool that we don't use all that much, most people just respond by email, but if you would like to give a line-by-line critique with line numbers and quotes from the source code, there's a tool that sort of creates a template for an email that you can then edit and send. Now, this process had a bunch of problems. This is the process as it's still in use by many developers, and it was the only process we had about a year ago. So Googlers love to work from home or at odd hours or locations. And especially if you're on a laptop, on the VPN, the tools for diffing don't work very well. You end up what you can do is stare at unified diffs in text form, but the tool that does the side-by-side diffs doesn't work very well in that situation. Another problem that is universal is when you do a line-by-line critique of a piece of source code, it's very tempting to say, on line 65, please change this. Line 512, I don't think you need to do this. By the time that email reaches the author, maybe the author has already made some other changes in response to a different reviewer, because there's sometimes multiple reviewers for one change. Or maybe the author responds to the first change request first and has to insert 40 lines of code, and now line 512 is suddenly 552. That's fairly painful. It also means that if a month later you read back the emails, they make no sense unless they actually contain integral quotes from the source code. Finally, and this is sort of the killer, unless you keep backups of intermediate versions, it's sort of, you get the standard problem. I don't know how many people here have had to do things like review academic papers. One of the problems is either you write a paper or you're reviewing a paper. The first revision works great. As a reviewer, you're fresh, you read the whole thing from front to back. You scroll red ink all over the paper and you send it back to the author. Now the author makes 500 minor changes. Then you get the same thing. The next time you're going to read it a lot less carefully. The third time, it's impossible to read it. As an author, it's pretty much the same thing. After a while, after working on the same paper or article or, God forbid, book for a while, you're completely blind for anything that's in there. Very much the same thing happens with source code. What every reviewer wants at some point is they want to be able to do a diff between the last version they reviewed and the current version, rather than being between the last version that was submitted to Perforce and the current version, because that's the same issue. So if you ask someone to make a few small changes, if you could diff between the last version you reviewed and the current version, you can immediately see whether they did everything else, everything you asked them, and you can also immediately see whether they changed anything else, which might be a red flag that they weren't actually quite done coding when they submitted it for review. Another thing is there's not much workflow management. It's very easy if your inbox has 500 messages that review requests or responses sort of get lost, and you get this very frequent situation where the author needs to ping the reviewer, well, have you reviewed my code yet? And sometimes the reviewer has to ping the author, have you read my response yet? So there is a lot of improvement possible. So, and I should mention that this idea was fully Neil Norwitz's. He suggested this as my starter project, and it sort of got a little out of hand as a starter project goes. He said it would be really cool if we could do code review over the web. It solves the VPN problem, and you could make the tool work in such a way that it solves many of the other problems too. So I set out to sort of think about how to do this, and the first feature I sort of decided I would definitely add was snapshotting every version that's being under review. So you have a whole series of snapshots. Another feature that I knew I definitely had to have was side-by-side diffs, because I mean, I had to sort of be at least on a par feature-wise with the existing tool suite. And although it wasn't perfect, the existing tool suite had a pretty darn good side-by-side diffing tool with nice colorization of the diffs, and also inter-line or inter-region diffs, where if you change one line into something else, it would show the sort of the subtle changes that happened within one line. Often, if there's just one spelling mistake, sometimes you can stare at a line for minutes without actually seeing, okay, where did it change? It's got to be changed. It has to have changed somewhere. You just sort of don't notice that some M was turned into an N. So now, to make it really attractive, and I should mention that I had a couple of people working with me who actually ended up doing most of the work of this feature, inline comments. And the idea being, while you're staring at the side-by-side diff, you can just click on any line in the code, and a little box pops up where you can scribble your text, your review of that line. You can do that. That's just a lot of JavaScript coding. So that turned out to, well, yeah, that's how a lot of stuff happens at Google. And then finally, the idea was also to make this a repository for all messages or comments related to one particular proposed change, so that you can always find everything back related to a particular change. All the email is automatically sort of classified. This email goes with this change list. A very important requirement of the tool, of course, was that it wasn't going to be all or nothing. I knew I would not have any success if I told all developers on November 1st, you're all going to use the web interface instead of command line and email. That doesn't work anywhere, and it certainly wouldn't work at Google. So I worked hard to have very good integration with email. So whenever someone adds a comment to a change list in Mondrian, it sends an email to everyone involved. When someone replies to that email, the reply is also stored back in Mondrian, as well as in a number of other places. So at this point, I'm supposed to switch to a demo. Let's see if the demo is actually working. I don't know if people in the back can read this, but this is still a very small monitor for Google standards. And the application is sort of designed to fit on a regular Google monitor. So what do we see here? This is what we call the dashboard. It's my dashboard. Everybody has their own dashboard. When you type the URL of the thing in your browser, all you have to type is the word Mondrian. And through some DNS and redirection tricks, it'll go to your dashboard. It shows a number of different categories. So the first category is changes awaiting your review. I'm apparently a popular reviewer. It looks like I have 10 or 12 things that I'm supposed to be reviewing. The next category is your changes awaiting review, which is things that I have written that I want others to review. Now, actually, some of these have already been submitted, but they haven't been completely reviewed. They turn yellow when they've been submitted but not yet reviewed. They turn red when they've been yellow for 4 weeks. The red ones really need to be acted upon. So I'll have to nag Mr. R. Peterson. So there's all sorts of other stuff in this UI. I'll show a little bit. You can, if you mouse over a particular username, you get their picture, and that sort of that was actually a bit of JavaScript we didn't have to write. That's all what was a standard Google thing. If you mouse over a change list, it shows you a little bit more about that change list, like the client, the user who wrote it. I think if you mouse over here, you see something else. So your pending changes is changes that I haven't even submitted for review yet. So I'm working on those things, and I'm not ready to have them reviewed yet. But they're already known to, the metadata is already in Perforce. And then finally, other changes is sort of a grab bag. That's things I looked at recently, things I reviewed recently, things that I submitted myself recently. I don't actually look at that very often. That's why it's at the bottom, but sometimes it's really handy to sort of, sometimes when you're done with the review, it's not completely done right away, and it's sort of, you can follow what's going on your dashboard that way. So if we click on a particular change, we'll see the view for that change list. Okay. So what do we see here? This is lots of Perforce metadata. This is the change description, not too interesting. Here's the list of files. This change list actually only has one file. If you want to, you can quickly see what the change was. Ask for an inline diff. But you can also show an actual diff side by side of the entire file, which goes on, and we haven't even reached the diff yet. So there are keyboard shortcuts that let you jump directly to the diff. Well, this is a very small change. So that's all there is in this case. Let's go back to the change list view. We can also look at someone else's dashboard. Actually, when you're in a sort of a customer service situation connected to Perforce, that can be really handy. Because more often than not, someone has a problem with the change list, and they actually forget to mention the change list number. So you can just go to their dashboard and see which change list they're likely talking about. So we see that Johannes is even more popular than I am in terms of reviewing. He's also got a whole bunch of pending changes. I can type anybody's name. I can type, what is it? I think that's an interesting one. And we also have a not so commonly used feature, but there is a feature where you can assign review to a group or a list of people rather than to an individual. You can also, okay, I didn't actually click that. You can also ask for the changes that are pending for a particular group. And some groups really use that because as part of their process, they never assign things to individual developers. They assign it to the group, and then one person occasionally checks that everything is being reviewed in the right order. So going back to my own dashboard, there are a couple of other things we can see. Let me go to another change. Excuse me. That's the same code I had in May, I believe. Well, so this change list has a lot of files. You can click on the first file and see a bunch of changes there. There's also a menu for navigation. You can quickly go to another file. Well, we're waiting for the network here. Okay, done. So let's look at some changes. Actually, so okay, there's one interesting thing that we see here. There's a list of history. These are all the different snapshots that were taken and stored in Mondrian's database while the review process was going on. This UI can use a little improvement. I'm not sure that the MD5 checksum is all that interesting. That's mostly debug information, because occasionally there's a mix-up when two versions of the file are actually the same. Like actually we see that version 8 and version 6 have the same checksum, so we know that that's actually the same file. Let's actually go back to the change list and find the one that has the most comments. This guy. So I can diff any two snapshots by clicking those radio buttons and hitting the select diff button. I can also, here are a couple of buttons where I can choose how significant the white space is in the diff. Anyway, what we'll see here is a couple of inline comments. Now, these have already been published, so they're collapsed, but I can open them up like this. So here is a comment I wrote and somebody's reply, and I could reply to him and start typing some more. And now I've added another inline comment. I can also go anywhere in the code and add a comment there. Now, these comments are stored in the database. They're not yet visible to anyone else. They're still drafts. That's why it says draft here. Let me see. How do I navigate to the top? So now I can go to review. I can do this for all files. I can really review a change list in very small time chunks. If I have 5 minutes, I may be able to review one file. And it will save all the comments I have at that point in the database forever until I actually come back to the change list and publish them. At some point, I'm ready to actually tell the author about my comments. So I click on Review and Publish Draft Comments. And here's a form where I can type some more comments that apply to the entire change. Maybe I'll say, this is great, except I have a whole bunch of style nits. Or maybe I'll say, this sucks, and here's why. So below that, these are references to the drafts, the draft comments I make. And what it shows is just the... Actually, no, I can actually expand these things and show the entire comments. Unfortunately, they weren't all that meaningful. So I'm not going to send this comment, but in theory, if I click on this submit button, it produces an email that that sends all this to the author. And the email is full of hyperlinks, so they can go straight back to Mondrian if they want to, go right to the file, to the particular comment they want to respond to. Let's see. Did I see everything? Yeah, there's one more thing that I'd like to show, and hopefully this file has some of that. Wouldn't you believe it? Okay, yeah, I think here I have an example. This one. That's a line that got changed a little bit, and I hope that the projector actually, yeah, the projector is pretty good. It shows with more bright highlighting the part of the text that was actually changed, and in less bright highlighting the part that's of the text that's actually the same between both sides. So much for the demo. So that was my starter project, and now it's more than that. How did I get to this point? Well, it seems that I develop only one web application every 3 or 5 years or so. So every time I have to relearn all the web technology. So, well, that's okay. So this time I learned some Django. The whole thing is put together with Django templates, but we don't really use anything else of Django. For example, we don't use a relational database. We have a Google internal backend for data storage. So that's another thing I learned about, how to use Google's Bigtable service. Another web thing that I learned about that I'm actually pretty proud that I could understand it was something called the Web Service Gateway Interface, which is it's a really nice thin layer between the mechanics of actually accepting HTTP requests, sort of the stuff that Apache is good at, and your application logic. And so WSGI lets you very easily switch between different forms of serve application hosting. It doesn't require you to use Apache. You can use anything. I don't know if I'm sure there is an IIS version also. And all those things can be done regardless of which application. The application doesn't have to know anything about what particular service technology is being used. It's also pretty CGI compatible, but you don't have to run it as in CGI mode. So even the first prototype, which had the side-by-side diffs, but it didn't even have the inline comments. It had a way of commenting on a change list, but there was just a button a link that said, go to the comment form, and you typed your comment in without any context of a particular file or anything, and then you clicked the submit button and it sent an email. Even that primitive thing was popular with a small population of people, and those were the people for whom the existing command line tools just weren't working at all. Mostly people working on odd platforms like Macintosh or Windows. So I'm not going to go very deep into the technical details, but Mondrian stores a whole bunch of stuff. It stores copies of the change list metadata. And one of the things you can do with Perforce is you can update that. You can add files to your change list. You can remove files. You can change the description. I think you can change permissions. There's a bunch of different things you can change. And every time one of those things changes, as soon as Mondrian sees your change list, which it only does when a user actually tries to view the page for that change list, Mondrian will notice that it has changed and update its copy of the metadata. It keeps all the versions because the metadata is also used to keep metadata for the file snapshots. Basically, it keeps the size, the mtime, and the MD5 of each file. And so another thing it does is it actually finds all the files in the user's workspace and does a stat on them and checks whether they have changed since the last time we took a snapshot. Or if we didn't take a snapshot at all, of course, it will definitely create a snapshot. Those snapshots are also stored in the database as long as the files aren't too large. I mean, everything at Google sort of has the possibility of growing beyond your imagination. So we've had a couple of times where suddenly the server was sort of stuck, pegging the CPU at 99% and it wouldn't go away. And we sort of debugged these things, and we found like, okay, occasionally someone is creating a change list with 100,000 files in it. And actually the reason that we had a problem with that was mostly that there was a quadratic word wrapping algorithm in Django. Yeah, they really need to fix that. We've had various other things. The most recent one of that kind was actually where we were trying to do an intra-line diff. We do intra-chunk, intra-region diffs. So if you have 3 lines that changed into 4 lines, maybe you reflow the paragraph of text, it will still sort of find which words are the same and which words were inserted or deleted. And it will separately show, oh, and here the white space changed. So what it was doing, unfortunately, it was doing a intra-line diff on something like 20,000 line file where every single line of the file had changed. So it was one big chunk. So we decided, oh, actually, if the chunk doesn't fit on your screen, you probably don't want to see the intraline diff anyway. So that was easy. So we store all these file snapshots. We actually encrypt them because we don't entirely trust what would happen to the hard drive where they're stored after the machine retires. Of course, we store some user profile data. We try to store, I mean, I'm not a big fan of applications that have lots of user configurability, because that just makes it more difficult to reproduce problems, because everybody has a different combination of features enabled. I mean, I'm sure there's quite a few Emacs users here. Have you ever tried using someone else's Emacs instance? It's impossible. No 2 Emacs's are configured the same. So all those things are stored in Bigtable, which is an infinitely scalable database service. Of course, we talk to all sorts of other things in the backend too. Of course, we've talked to the Perforce server. We talk to NFS, which is our way to get snapshots from users. We also use SSH because sometimes, and this is one of those areas where theory and practice are different. In practice, some users actually like to put their workspaces on their local hard disk, and then of course you can't access them through NFS. But we have another backdoor. We can actually remote log into everybody's machine, or almost everybody's machine. Again, not if it's an odd platform. So then we just use SSH to go there, except actually I think one of the changes I showed had a little warning message at the top and a button that said grab snapshot. That was about changes that were on somebody's local disk. Because the SSH thing is kind of expensive and takes a long time, we don't do that automatically like with NFS, but we just warn the user, well, you're not getting your automatic snapshots today. Click here to grab one explicitly. And in some cases, the SSH trick doesn't work either, and then you'll have to sort of revert to the good old mail around context diffs or unified diffs. So we have an option for that too, where the author actually has to upload a change. The whole thing actually consists of 2 servers, at least as far as I'm concerned. I mean, obviously the Bigtable service is a whole thing by itself, but the bits that are interesting to me is the web server and the mail server. And the mail server receives probably like 10 or 20 emails per minute, scans the subject line looking for a change list number, and stores them in the right place in the database. So I think I've already explained all the snapshots, including what if they're not on NFS, what if you can't SSH. And one thing is, everything is stored forever. It's always good to be able to go back to history, even if it's 5 years ago. That's basically the same thing that a revision control system does anyway. So this, in some sense, you can think of Mondrian as a revision control system, for pending changes. And other people would like to do that within Perforce using branches. We didn't have that option, at least we chose not to use that option. So we had to build something outside Perforce, but it's still a revision control system of some sort. So again, it just keeps everything forever. And once it's in there, you can't edit it or delete it, except some system administrator might have a backdoor. And this is, of course, also important for the auditings. The user interface is actually mostly very traditional HTML. We do use CSS a lot. It's all done using Django templates. And we're not using Apache. We're just using a completely Python-based multi-threaded web server, which is mostly part of Philip Eby's WSGI implementation of the WSGI standard platform. And so it's just pure Python code that reads the socket that handles the request. And since most of the work actually goes on somewhere in the backend, that's not really a problem. I mean, Mondrian is one of those odd applications where if there are performance problems, they're almost never in Mondrian itself. Mondrian itself has a couple thousand users. So the number of queries or requests we get per second is really not that big. So we don't have very big demands on the web service infrastructure. Everything is sort of waiting for other servers to do their thing. So we can actually handle a lot of requests in pure Python code on a single machine. There is a lot of JavaScript. A little bit of JavaScript is used for simple things like expand and collapse comments, or the inline diffs that I showed in the change list view. That's a little Ajaxy thing there. When you click on the show inline div link, it actually makes another HTTP request to the server and inserts the response right there in the page. So it is limited in the number of browsers it supports, but it works for all the modern browsers that are in actual use at Google. Now, the one place where there's a lot more Ajaxy stuff is the file view, the side-by-side div, because double-clicking on a line is something that has to be done slightly different on each browser platform. And things like keyboard shortcuts and showing a focus of where you are. I don't know if you noticed sort of a big horizontal blue line that moved up and down in the side-by-side div. That's where the majority of the JavaScript code is all devoted to that single page, handling all the different kinds of all the different variations of inline comment, like create an inline comment, reply to an inline comment, discard one, cancel your change request, and so on. And all that is very important because when you're viewing the side-by-side div of a 10,000 line file, you really don't want to have to re-render the entire file when you made one change if you're planning to make 20 changes in that one page. So a little bit of the details. How do we actually do those inline draft comments? The whole thing is rendered as tables. And we actually use 2 table rows for each line of text. The first row contains the text, and the second row starts out empty, but is where the comments will grow if there are any comments. Every cell, no, I should say, every cell has a unique ID, which is something from which you can tell that it's left or right, and then the line number. That is used by the JavaScript code to quickly find out where you clicked and where to insert things, and also to identify your comment in the server. Another thing that we do on the server side, of course, is we associate the comment with a specific snapshot. So the comments always stay on the snapshot where you initially entered them, so there's not the problem that the line numbers become invalid over time. You just may have to go back to an older snapshot to see all the comments. So the mail server is a much simpler program. Again, a pure Python-based server turned out to be fine for the amount of traffic that we're processing was something called SMTBD in the Python standard library written by Barry Warsaw years ago. It's actually single-threaded. It's based on async core. It can handle many simultaneous connections, but it doesn't actually handle them completely in parallel. Once one particular connection has a complete message received, it will make a callback, and that's where our code gets called, which then scans the headers, parses the subject looking for a change list number. And I did a lot of early research basically trying to figure out what kind of patterns to look for in the subject, because these emails are often generated by people instead of by programs, so you can't count on all the email to have the same format in the subject. So there's a couple of things that we just had to ignore because you can't parse it out. And we actually have a whole bunch of odd email that somehow gets sent to the same email alias that we're not interested in. Once it knows the revision number, it also actually has to, these days, it has to find depot number because there's actually more than one depot. It just parses the email body. It does, if it's a multi-part MIME format, it actually tries to look for the first text part, which is the most likely and the most useful thing to keep as a comment, and then it saves the whole thing as yet another comment in the database for that change list. And from Mondrian's perspective, it's completely indistinguishable from something that you entered through the web user interface. Oh, and one more very important thing, what it does, that this is the place where the reviewer's to-do list is maintained. Every reviewer has a to-do list, which is actually, that's almost the only information we maintain for each user. The to-do list is which things you have to review. That's the most important part, and that's the only thing that we can't easily recover by other things. Like you can just query the Perforce server and ask for what are your pending changes, but you can't query the Perforce server to ask for what is your to-do list, what do you have to review, because it's not a concept that the Perforce server understands. So that all gets triggered by the email. So occasionally there is an issue when the email doesn't get delivered. People's to-do list is out of date, but we're getting better at making that not happen. So a note on performance. Despite the whole thing running on one box, well, apart from the persistency, the big table all runs on boxes and I don't even know where. But the core functionality, the web server and the mail server together run on one box. And usually the CPU load on that box is less than 50%. It's going up because we're seeing quite a bit of traffic. At the moment we have, I think, about almost 1,400 unique logins per day and over 3,000 unique logins per week, I believe. And this is still slowly going up. I think it's just growing with the size of the Google engineering force. And basically, almost every Google engineer is using Mondrian on a regular basis. If it's slow, it's almost always waiting for Perforce, because unfortunately Perforce is the one big centralized resource that Google didn't invent. So isn't all that great in being scalable and distributable and all that great stuff. A few other things are slow. Sometimes diffing a large file can take a long time, or generating HTML for the dashboard is actually pretty intense because there's a lot of information crammed in a small space with pop-ups and everything. So that's a fairly complex piece of HTML. Everything else is pretty simple. So it being a multi-CPU machine, in practice, even if one thread is very busy doing diffing for a particular file for half a minute, other users still get decent response because they just get served by other threads.